the chat below, and we'll try and get to them as they come. If not, drop them in the meetup group, and we'll see. Billy's time is very important. So we also want to make sure if Billy can answer later, we get someone else too, okay? So I just want to say as well, thank you everyone for coming to our event today. These types of small group discussions couldn't happen without you. My name is Tristan Lombard. I'm the Director of Community here at Provar, and very, very excited about today's topic, why developers should love testing, right? So you're going to get some pragmatic solutions today, as well as answer a few questions from our main guest speaker. Just want to quickly shout out Provar. Thank you so much for letting and hosting these types of opportunities. If you're looking for easy ways to make Salesforce testing work for you and your teams, be sure to check us out. And also too, we always want to give back to the community. So in addition to these types of discussions, we also launched University of Provar. It's a great way to get certified, learn some new courses at your own pace. So be sure to drop that in the chat below as well. But that's my marketing hat off. To the main event, y'all. So I am so excited to introduce our speaker. Billy Kornado is a Java developer advocate for the Java platform group at Oracle. He has over a decade of experience in Java. He's bringing a passion for, all right. Thank you, everyone. Feel free to mute your microphones. I'm going to do that again. TLDR for our Billy. Billy, outside of work, enjoys traveling, playing kickball, cheering on the Kansas City Chiefs. Wasn't the best year. It's okay, Billy.
It ended badly.
He got so close, though. Billy also co-organizes the Kansas City Java Users Group, and you also are a volunteer for the KCDC.
Yeah.
So, yeah, a lot of subscriptions. So y'all, tickets are still available for KCDC. I know you just finished around for CFPs, so definitely check it out. It is a global event. But without further ado, Billy, how did I do on that intro?
That was great. And with that said, since we only have 30 minutes, I'll go ahead and get right into it on why developers should love testing. But yeah, thank you for the invite, Tristan. I'm happy to be here. Again, name's Billy Kornado, Java developer at Oracle, and you can find me on Twitter at Billy Kornado. Please ask questions. I'll be monitoring the chat log. So as you have them, please ask questions. Like, I'm here for you to help learn about why you should care about testing. Again, reach out. You can DM me at Billy Kornado. You can also email me. And the link to this slide deck is here. And I also posted it into the chat as well. Just some things, like if you believe it's an intense desire to know more, here are some great links on Java content. Of course, I'm a Java developer advocate. So, that's where my heart is going to lie, at least as far as programming goes. A lot of great content from my team here at Oracle. So definitely check that out. So why write automated tests? Well, and we have to consider it is a substantial time and effort to write these tests. And it will also take a substantial time and effort to maintain these tests. At a high enough level, you might be spending as much time writing automated tests as you are actually writing real production code. So if your code is perfect like mine, I've never written a bug in my life, why should I waste time writing tests? Well, let's actually kind of look at what a manual deployment process would look like. So, you're going to have your developers, they're going to commit the code to their repository, and you're probably going to have some sort of build server that will automatically, may see that and build it. But then you're going to have a manual process of testing to actually get that deployment to prod. And here, so beyond the fact that it's going to take hours or possibly days or even longer to do that, there is a huge amount of human effort involved, dozens to hundreds of hours for every time you're going to want to do a deployment. And so within this, then, the subtleties of where, in my experience, this can cause a problem is what I like to call the dependency iceberg. Certainly as a developer, I kind of long felt that all this code that I'm spending all my day writing, when I deploy to production, that's primarily the code that's going to actually be out there executing on our production servers. But the reality is it's just the proverbial tip of the iceberg. Below that, all the code that our code depends upon makes up a much larger area of the actual code that's actually running out in production. And in this area is where you're going to need the security patches, performance enhancements, and in feature enhancements. But really, the important thing there is security. That almost every time you hear of a security exploit happening, it is like over 90% of the time, 99% of the time, particularly when it's external, some sort of external exploit happening, it is happening because it's like the underlying dependencies are is what's being exploited. Because like some external hacker, they're not going to know what the code I wrote, is. They may work for certain things like a SQL exploit, like our SQL sending. I'm blanking on the specific name, but otherwise they're really going to be looking to see like, oh, what version of an application server I'm using, what version of a framework I'm using, and then finding to see if there's any exploits about that out there. And that's how they'll, compromise your application. So because of the high effort involved in manual testing, and when I say manual testing here, I'm talking about manual testing as a gate to get to production, it strongly disincentivizes keeping dependencies up to date. You just don't know necessarily what's going to happen. I mean, if a patch version is an update, maybe a developer will just kind of do that, but you just don't know that small patch version update could break something. So that leads developers to not wanting to update that, or organizations not wanting to update that, because then that would have to be retested, or you're not going to do a deployment just to kind of get something up to date to patch something, because again, that will mean dozens to hundreds of hours, because you're going to be like, we have to make sure that we're not going to accidentally explode production by pushing this out there. So by going to an automated deployment process, though, along with it being just usually much, much faster, there's minimal to really no human effort involved. Most of the human effort is going to be involved here in the developers updating and making a change to the code, and then, committing it. And then it should go through, hopefully, a fully automated process to deploy to production. Maybe not necessarily can fully get to that. I mean, getting to that high of a level is difficult. Even the famous like FANG companies like Netflix, it took them years to kind of get to where they can have fully automated deployment processes. And even then, they're not perfect either. As in like just even organizationally, they sometimes don't fully live up to that kind of standard. So it may not always be that, but at least getting to the point you can say, okay, we can at least upgrade dependencies necessary without having to require some sort of manual testing. That would be a huge win as well. But there are some other additional benefits with automated testing, kind of beyond the speed of it and, maybe keeping the dependency up to date. And the two big ones I want to point out that people just don't really think about is, one, automated tests are auditable. So, I mean, this is both good from a debugging and just organizational perspective of like, hey, these tests are failing. You can go look at the test. You can look at the code of the test to see what is this test trying to do. You can look at the reports to see when these failures are happening. You can look at logging to see, what is the results of these tests happening. You can't necessarily really do that for manual testing. You can't, get into a person's brain and know exactly what they did to do a test. They might have thought they actually went through whatever this test script to say like, okay, we need to test these things, but maybe they did it in the wrong environment. Maybe they accidentally skipped a step. Maybe, there's just 1,000 things there that are completely innocent. And then there's also things just of human laziness. They don't want to have to go through like that 20-step process every time. Maybe they skip a couple of steps that they don't think is important that turn out to be as well. And of course, it's repeatable. Again, humans, we're not always so great about doing the exact same task every time the exact same way. Whereas a machine is going to be much, much, much better comparatively. So by actually automating it, we can just say, okay, it failed, run it again. Did that still fail? And if it did, then okay, you kind of have confidence something changed in the code. If it succeeded this time, well, maybe you need to update the test or something going on there because you're having like a flaky test or something kind of going on there. You can also run it against different versions of the code potentially as well. There's a lot more. Because the test isn't changing, you can have at least one area where you can kind of start from on maybe what could be going wrong. Something that's also talked about with automated testing is how many automated tests should you write? Sometimes you may be like, oh, an arbitrary, like you should get to 80% test coverage, or there could be how many tests where you have like those pyramids of like, oh, it should be a lot of unit tests and then some integration tests and then some end-to-end tests or something like that. But fundamentally, it's whatever gives you confidence to deploy to production without some sort of manual intervention. Manual intervention being we need to have manual testers check this out before we go to production. Um, and that's going to vary from with organization to organization, and of course, from application to application. You at your organization have some sort of service that handles all the credit card transactions or payment processing. That's a really important application. You don't want that messing up to where it's double charging or not charging or anything like that. Like, so you are going to want to have a whole lot of automated tests around that one to make sure it's correct. On the other hand, you may just have a batch process that goes through and checks to see if you're sending out emailed advertisements or the newsletter or something like that. Okay, it's not like that application doesn't matter, but the threshold for what could go wrong with it is so much lower. If you forget to send out like an email, or if you send out it twice, you're talking minor inconvenience that, maybe some people may not necessarily notice versus, something involving money or something much more significant, like a person's confidential information or something like that. So there's just no arbitrary limit. They can just say, you need to get to this and, you'll be fine and great, because that just doesn't make sense. It ignores context. One thing is like the goal, even if you get really, 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 really great with automated testing, like the goal isn't to completely replace manual testing. It's still going to be needed. It's still going to be needed, but it's going to be exploratory. It's going to be something that's happening in parallel to your development process, where you're going to have some region where people are just going to be it could be like dog fooding, where you're using your own application to test it out for your own day-to-day work, or just having something like that, just to where you're kind of just making sure, because there may just be, otherwise you're going to be only testing the paths you know about and may not run into certain issues that you haven't experienced yet. So how do you, and then just also remember, you need to love the test you like, or you write. And one of the things, and something a mutual friend of Tristan and I has said, Angie Jones, is like, you need to treat your test code like production code. You can't just be like, oh, it's just test code, I don't care. I'm just going to just type it out, and I don't care about any sort of reusability or refactorability or readability. You have to treat it as well as you would treat your production code. Of course, there's still going to be certain things you can't necessarily do or want to do with test code, but you just don't want to, just treat it like a second-class citizen. Make sure you write human readable tests, writing good test names, using a fluent assertion library to say, just so make it absolutely clear what you're trying to test. So my experience is as a Java developer, and I've used something like JUnit most of my life, or most of my time as a Java developer. And like one of the most confusing assertions they have is assert equals, where it takes in then two arguments, but it's not always, for the longest time, I had it transposed as to what the expected versus actual value was in this two different arguments. And so like sometimes I would make for confusing error messages. And so, there's no right or wrong way as to how that should have been designed, but that's just the way I initially viewed it. But I use like other assertion libraries like assert J, again, this is Java, where you can use like assert that, and then, the expected value is equal to this. So it becomes human readable to where it's not ambiguous as to what is the expected value versus the actual value you're trying to test against. So doing that stuff is very helpful. And, of course, just, again, making time that the test case that you write aren't dense and just, you can't really understand what is going on. The last thing is write reliable tests. So fundamentally, if you start having flaky automated test suites to where you run it once and it succeeds, and you run it again and it fails, you're not going to you can't really rely that much on that automated test suite if it's a larger issue. Occasionally you're going to have some amount of tests that's not going to happen to you, you're going to have to fix. But by writing reliable tests, what you want to do is avoid depending upon live services. And luckily, there's a lot of great frameworks out there that can do a really good job of simulating existing services on your local machine. It started in the Java world, but I think it's now available in many other languages. It's called test containers, where it can allow you to spin up and tear down a Docker container within the lifecycle of a test. So that way, when you're having to test against a database or cache or some other service, you can have this service, or you can have a Docker container that matches that service to a very high degree of what it will look like in production, spin up, test against it, and then shut down afterwards. And that way you're not having to configure it on your local machine. You're not having to call out to a live service, which could not have the right data, could not be configured correctly, could be overloaded, could be down. A lot of things can go wrong when you're connecting to a live service that can cause it to fail. That has nothing to do with what your test code is, or what the code you're actually executing it hasn't changed or anything. There's also other things like contract-driven development, where you can write a contract that is machine readable that it can actually then be used to test your service against. This can be done for RESTful services or messaging, to where it can be like, okay, if I send this kind of request, or if I send this kind of message with like these fields at these values to this endpoint, or to this messaging or this consumer, what's the response I should get be back? And that way again, you're not going to have to rely on a actual existing service to test against, which again can be unreliable. And also early on in the development process, this can be extremely helpful as well, because you can easily write out these contracts and then have that be used as a simulated service to test against, while maybe the back end or front end is taking time to complete their process. So you can meet that. And because you can actually test against this contract, it's not like, oh, this is the pseudo mock thing that we kind of think this is what it's going to look like, but the actual real thing is going to be completely different. Both the client and server are both actually testing against and developing against that contract. So you can actually have confidence that it's going to really match what it's going to look like. I mean, again, it ultimately comes down to the effort and time you put into these contracts to make sure that it matches that. But you can actually have confidence, if you take the time to do that, that is what it's going to actually look like with the real actual service, the real actual client. So that's it. If you want to get a copy of this slide deck, it's at this location. For some of the other services and concepts I was talking about, you can check them out here at these other hub repositories. And one thing I didn't really get a chance to talk about, and I don't know if there's equivalents for other things besides Java, but one area that's always been difficult with automated testing is performance testing. And one thing that was recently released is called JFR Unit, which stands for JDK Flight Recorder, which is a utility for doing like really in-depth analysis on what's happening within a Java application, like how much memory is being allocated, how objects are being used or destroyed, threads. I mean, really in-depth analysis. A difficult thing with performance testing is it's like, oh, if I run a performance test on my local laptop, okay, that may, whatever results I get may have no relevance whatsoever to production, because in production, there could be completely different network architecture, because I'm calling from here to Florida for the database, and I have a service up in Seattle where it's all local machine. So network is taking no time, but it would take a lot of time for production. Or on my local, like I might be thread count limited, but in production, that may not be an issue at all. So if I make my threads really efficient, that might actually be slower and worse in production, because that's not an issue. With JFR Unit, it only matters that your JVM is the same, because it's really only testing how the JVM is behaving. And so you can get a good idea. And then over time of like, oh, okay, this same test, like all of a sudden now it's doing a whole lot more or a whole lot less than it was previously, as far as resource usage or whatever metric that you're kind of looking for. So I don't know if there's any sort of equivalent for other languages if you're coming at this from, some JavaScript, Python, Ruby. So I can't claim to that, but it is something worth to kind of think about if there is some sort of observability framework for what you're kind of using. Does something like that exist to where you're kind of have something sort of that's reliable between different regions for doing performance testing. So that said, thank you, and hopefully we can have some questions now.
Oh my gosh, round of applause for our Billy. That was absolutely wonderful. Yes. And you can stop sharing your screen out for a second, friend.
Oh, sir.
Is this deck going to be available offline? Is that something we could drop in the chat or your repo? Is that all there?
Yeah, I already put it into the chat log, so it should be like the second message there. I'll copy it just in case because I don't know if people came in later, if they'll see it. So yeah,
Wonderful.
there it is.
As
Yep.
you can tell, our professional over here, Billy, we see.
I've been doing it for a little bit while now.
And then I'm like, but can you do it in 30 minutes? Because people have confidence. With that said, we do have a limited amount of time here. Again, if we can't get to everyone's questions live, you have Billy's information there, and also too, I know we're starting a new meetup group, and who hasn't started one?
Exactly.
Everyone. But we do have a very special VIP guest here today, Billy. Kyra, how are you? I know.
Hi, I didn't know I was a VIP guest. I was just checking out what you guys were up to.
Yes, I just wanted to say thank you so much for being here. I know as a fellow KCer, I'm curious for you, Kyra, when it comes to do you have any questions for Billy around, strategies from a QA perspective to kind of help developers fall in love with testing or any challenge?
I would say honestly, I don't know. So I've only worked at automation testing with one company, so I'm definitely getting my feet out there. I'm actually transitioning to a new role at another company, so I'll get kind of more well-rounded experience versus just one side, so to speak. I thought everything was really good. I was just curious. It's interesting to see it from the developer's point of view as well, which is kind of some of the things that maybe are turn off, so to speak, with testing. I'm glad that Billy, that you said something about manual testing, because I think a lot of people equate manual testing to bad testing, and that's not always the case. I think it's just another tool, like how you said, exploratory testing. It's not going to go away all the time. And even just taking into account the cost of automation testing, because you still have to do the maintenance and make time for that. So I thought it was really good. Just very good intro. I really liked it.
Thank you.
We always have to keep things like this. Hello, friend. You go ahead. Lucas is like, don't call on me. I was a school teacher back then. Yes. Any questions, Lucas, for our Billy?
I mean, that was awesome. I'm dabbling in coding right now and doing IT. I guess one thing at the foundation of all that coding, you've mentioned a mix of automation and manual. Is there something that you feel like hits home the best for, I would say, maybe a small business?
So I think at every level, it does make sense to invest in automated testing. Even a really small business could benefit from it once they at least get to some sort of stable point as to what their product will look like. If you have no idea, you're so early that you're rapidly in that development phase, maybe automated testing can be a bit difficult, especially, with limited capital and runtime, that you can't put that into something that necessarily won't end up making you money. But even at small business level, it can still benefit from it because, small businesses could just be much as exploited from hackers when it comes to that stuff. You still have valuable information like, addresses, username, passwords, email addresses. So it's not like hackers are always going to just be going for Amazon and every large company you can think of. So it still benefit from that way. And again, I think some of it just kind of comes into the buy-in, kind of explaining, what I was talking about with the dependency iceberg. I think that's just one of the most subtle issues that people just don't think about, that when you rely upon manual testing, it's really hard to keep updating. If you kind of console about that, hey, if we don't have this, we can't really stay up to date. It's going to potentially leave us to be exploited. And I know, at least from my Java world, with every new release of Java, there are pretty substantial performance gains, which can be cost savings, particularly if you're running out on cloud. On Amazon, that means, less memory usage, less CPU time, and all that stuff, which can have real money savings. So definitely it can be also worth it for that it can be a real cost savings as well. Like I said, that just, again, from the Java world, a lot of Java organizations are on Java 8, which was released back in 2014. And the most recent of Java is Java 17. And like if you ran the literal exact same code on Java 8 to Java 17, like you would be using about like half the memory and you get more throughput. Like there would be pretty substantial benefits from that, just from upgrading without having to make any code changes, if that's possible, because sometimes you still have to update dependencies. So I got a question. What are your thoughts about testing and using cloud native services, being able to replicate those services in the dev environment? Again, I know a lot of organizations or a lot of developers, it can be easier to just call out to that direct, like cloud database or cloud, CAS or whatever kind of thing you're using. And you can just still run into reliability issues. It can be hard to maybe get that cloud real service into a specific state to say like, what happens if I have a null value field for this record? How do I test that? And putting that out there in data could cause all these issues. So being able, if you can, I'm pretty sure test containers is pretty polyglot. Like I think it works on JavaScript and Python and all that stuff. I would highly recommend using that because you can run it locally. You can have where you have your container repository that can highly match what it would actually look like in production, to be like, okay, we are running this specific version and we can have it set up in this specific way to make sure it matches really close to what it would actually look like in production, and not just like, oh, we're using a Postgres database, but it's not configured at all to resemble that. You can actually have that as a container repository, pull it down and then test it against it. I would recommend against that, just be doing that versus actually live services, just because there's so many potential issues with live services that can affect over the long run the reliability of your automated test suite.
Can I just say, first and foremost, I know these meetings go by so quickly. We like to keep them bite-sized for y'all. I want to say, y'all, Billy, you have his Twitter there. Tune in Monday for a Java sip with this one. And I want to say as well, Billy, just as we wrap up here, as a QA leader, what's the one sentence you would say to devs to get them to start looking into testing?
If you want to be on the latest and greatest, invest in your test so you can actually update with the times.
Wow, Billy. You're not playing. You're not playing. I want to say I appreciate you all so much for coming out to these small group discussions. We like to keep them short here. If this was helpful for you as well, please show Billy some love on Twitter. You can also get his repo as well. I want to say, Billy, thank you so much for giving us some of your time. You're wonderful.
Absolutely.
Appreciate you and the fur children. And I'm excited to see you at KCDC this year. And y'all, tickets are still on sale for KCDC. So
yep, please come.
One. Yes. Ta-ta for now. Expect more events soon in our meetup group, and we'll see you soon online. Bye, y'all.
Bye. Thank you. Have a good one.